Hello everyone, I'm Xiaogang. Okay, in this lesson, we won't rush to write code. Let's first spend 10 to 20 minutes going through this document with you, section by section. Actually, after you start working daily, your development process is usually like this. That is, when you develop, a leader usually assigns a topic to work on. Then our product team will pull the tech team to do a feasibility study. After the product feasibility study ends, the product team will start scheduling a study like this. This is what we call a PRD, or a high fidelity prototype for requirements. Then, with this in place, they will list their requirements. After listing the requirements, there will be some images, PPTs, and the like to let you know what effect you need to achieve. Then at this point, we the programmers start scheduling, dividing it into several versions, and then start working on it. Then each version includes some content, and before we work on a version, usually this document comes first, but in practice, it's different. Actually, this document might be the product document. Then basically during our development process or before development, we only write such a API document, and this API document is particularly important. Then during your actual development process, if you need to interface with other vendors, it's generally done based on this document. We usually don't let someone directly guide you, telling you step by step how to write it. How to write it, generally it might just be like this. They throw an interface at you and tell you what parameters there are. Then show some example code at you. So this is a rare opportunity to take everyone through it, this kind of standard documentation, and we as humans look at what this document is for. It uses this phase liveness detection algorithm and can detect faces, whether there is a face, and then provide a reference for the confidence score. So this document is divided into several parts. You can see some overall interface description. Then it's a general health description. Then this place is our req. In, then this place is the recipe info. Then there are common issues. It's roughly divided into these parts. Then what is actually the most important? The most important is actually this error code query. You can see this is the most important because many times you don't know where the error is, but in the respire info it returns. That will be this error code and some related reasons. You need to have this thing to know, to be able to make the connection. Otherwise, many times, disassembling this interface is very painful. Okay, next, let's take a look. First of all, it uses HTTP. You can also use HTTPS. We'll just use HTTP here. If you want the S, just add an S directly in UE. If you encounter SSL certificate errors, then you need to copy a file into your project within the engine. Then take this file and package it together with your project. This might be able to solve your HTTP SSL certificate error issue. Okay, now we can just use HTTP directly, and here you must use a domain name. Don't use an IP, because the IP corresponding to that domain name actually changes, so we just need to use the domain name directly. Then it's the request line. Obviously it's a post request, and it requested this line. Actually, it's this line. That is the part after the domain name, meaning the front part is the domain name. Usually it's the domain name plus the port. Just write the domain name here. Then here is the request access point. It's this location. It connects layer by layer to this location and this authentication mechanism. We'll talk about it later. Don't look at this authentication mechanism for now. Then remember the encoding. See, it's UTF-8 actually in UE5. It has the UTF-8 encoding, but we actually use T2. If your format is unified, it's better for saving, and the language is actually not limited. You can use any language. As for the image format, any image will do, but the image size is already limited. That is, after we encode this custom image data, it cannot exceed the reference. As for the image requirements, we don't care. Just a normal photo or selfie will be fine. So this is actually the query string. The part before is actually the domain name. After the domain name, how is the query string formed? There is a question mark here. It means that what follows is the parameter for this visit. This question mark carries the parameters. The parameters are very similar to command line arguments. It's essentially key value pair. So the first key is authorization, so it is anyway, it's information related to the signature, even if it's encrypted. Then the second one is host. The host parameter actually requests the host. You will find that it is actually its domain name, right? The next data is our timestamp in a format like RF3123. This time format is supported in UE5. We can directly use data time to convert it. So you can see that the authentication mainly consists of 3 parameters. One is data, one is host, and then there is one more There is also this thing called assertion. So if we look at this complete rule, it's actually quite simple. How is it completed? First, you need to prepare these two parameters. One of these two parameters is hard-coded. The other is obtained based on time. Then you need to prepare the API key and secret. So how does this assertion work? Assertion is actually a piece of code like this. First, this is also a key value pair. The first one uses this method to put the key in, and this is a constant. This constant means it uses this encryption method, and the encryption algorithm it uses is this one. The encryption method uses host data request in line. So it is said that through these two, it knows that it was encrypted together. And here is the signature. Then the signature needs to be calculated separately. Yes, so how is the signature calculated? The signature mainly involves a host and data and require in line. That's what the signature looks like. So suppose your URL is this, and your data is this. Then after your signature is generated, it will all be such a signature. Why does this thing have this? It is because of this transfer server. There is a /n here, so it creates a line break. So it is 3 lines. The first line is the host you were looking for. The second line is the time. The third line is the address you requested. That is the request in line. And once you have it, it uses this HMC, which looks up HMC, then the SAT256 algorithm, and then uses this API secret. Note that this uses the secret to encrypt this original token, this thing here. After encryption is complete, you obtain this SIM digest. After obtaining the SIM digest, then encode this base 64. Then the result of this encoding in the middle is that after encoding is complete, its structure signature is this signature. Then finally you piece together the original authorization code, which looks like this. After piecing it together, it then performs a base X4 encoding. Then the final authorization it obtains looks like this. Finally, you take this authorization together with the host and date parameters we mentioned earlier and concatenate them into our URL. And this is actually its first level service. This place is the first level service. During the first level service, it will, if the first level service authentication fails, it will return the, which means no authorization or parsing failure or timeout failure. This is the first level service. The first and second level services we wrote in the previous chapter. You should remember them well, right? That is the first and second level services, right? So if the first level service returns an error code like this, then for our first level service parsing, it means directly parsing the client's UNBA. This token is incorrect or something on the client side. This saving type was not found. We consider it to be this first level service failed. This is a first level service. Next, let's look at the parameters of our second level service. As for the second level service parameters, actually, this part is written in our body. It's written in our counter, and it is a string. So actually, this is a large object. And here there are 3 objects. The first one is the header object. One is the parameter object, one payload. Obviously, as the name suggests, they carry different parameters. This header object, you can tell at a glance, it is the relevant information of APC. As for the parameter thing, it requests business information about the interface. Then the third payload is obviously complex. It is about what data this interface should use. So actually, your body has these 3 pieces of data. Then the corresponding JSON, its fields, and what they mean. Right, then you just write them one by one. We are using UTF-8 defaults here. That's fine. Then pay attention to this data here. It is a image. It is a base 64 encoded binary data. And here are some status codes. Just follow the documentation for these. There's nothing much to practice here. Just skip it, then the return result here. You can see there are 2, right? The first one is the header. Actually, this header, we can understand it as the first level service. The first level service tells you this one is successful. Then the secondary service. This is the data of the secondary service. As for this data, all of these are defined by itself, objects nested layer by layer. So this tells you that this data looks like this, and here it is JSON and UTF-8, and the method is raw. Then you can see, there's nothing much to say about this. You can see. Then you decode this side. Then you take this string, you see another layer is wrapped here, right? After decoding this, then what you get back is another node. This node is the data you actually use, and this data, it will indicate whether this is successful and also what the confidence level is, right? Then the coordinates of the face bounding box on this cushion, X and Y, then W and H. So that's how it is. After parsing this part, its data looks like this. Then mainly look at this past one. which is whether there is a face or not, right? And this is a common issue, which is what we often call question and answer. Okay, basically, it's still quite simple. You see, it also sends a request and then returns a result like this, right? And there are no issues at all. Then we will start writing for everyone. As for writing, we actually divide it into two parts. One part is the encryption process, and the other part is the integration and debugging process. Okay, we'll stop here for this lesson. Thank you, everyone.